Hello everyone, my name is Vishnupriya and I am a student of Bangalore Institute of Technology. Today we'll be studying about a tool, we'll be exploring this tool that's called as jFAST. So jFAST is a simple, easy to use tool for creating, editing and simulating finite automata and state machines. It provides a simple and intuitive method of interacting with numerous types of supported FSM, which is including DFA, NDFA, PDA, state machines, and also Turing machine. So we are first going to look into the installation of jFAST and also about how we are going to work with it. So first let's look on to how to install this jFAST. So firstly, we have to open our Google Chrome or any web browser that you would want to open. So now we are going to search for jFAST. So when we open it, the first option that we get on top will be jFAST, a Java finite automata simulator. So you have to click on this option, and when you click on this option, you will get various options or various options onto your left, like what is jFAST, about jFAST, screenshots. You can read about them. So since we are interested to download it, we click on this option. It leads us to another tab. So in this, you can see the option that's written on the green button, that is download the latest version. So we click on this. So once you click on it, your download will start shortly. So it's shown over here. And after a few seconds, our download should be starting. So we can see that the download has started and it's a little small file itself, so it's not going to take a lot of time. So we need to wait till the download is done. And once it's done, you can click on this option called as open. So it is going to open a dialog box which is going to read as jFAST setup. So here you can see welcome to jFAST. So here you have to click on the next option and it's going to ask for the folder where it wants to store it. So we are just going to use the default folder itself. So we move on to next and we click on install. So here we have to click on yes. So it is completed. So it might take a few minutes for some people. So now we click on finish. So now our installation of jFAST is done. So now let's open jFAST and see how to work with it. So here in the search bar, we are going to search for jFAST. So here, whenever the jFAST is going to open, it normally is opening for DFA. But in this video, we'll be designing a Turing machine which recognizes the language 1:n, 2:n, and 3:n for all n greater than or equal to 1. So to change from DFA to Turing machine, we have to go to the file option and click on new. So when we click on new, here we get the option to select which automaton. So here we are going to select Turing machine because that is what we are interested to. So then we click on accept. So here we see that it got changed to Turing machine. So if you want to know how to work with it, there is also an option here in their official documentation. There is something called as tutorial where we can read as to how to work with the jFAST tool. So if you want more information as to how to work with it, you can go through this. So since our intention is to design a Turing machine which is going to recognize the language of 1:n, 2:n, and 3:n for all n greater than or equal to 1. So first we need to design the Turing machine on a piece of paper. So we've already designed a Turing machine, so we will not be looking into the details as to how to do it. But now our main aim and objective will be to implement it by using the jFAST tool. So according to this, so you have a few options over here on top. This is the first option which is used for creating the new state. The second one is for creating the transition between two states. The third option is for labeling it. The fourth one is called as load sub automaton, which we are not making use of it. And the fifth one is for setting up of input alphabet. And the last one is to set the input string. So let's start up with designing our Turing machine. So for this Turing machine, we would require Q0, Q1, Q2, Q3, Q4, and Q5. So these are the 6 states that would be required. So we are going to make Q0 state as the initial state and Q5 state as the final or the accepting state. So let's start with the states. So we require 6 states, the first one being Q0, then we have Q1, then you have Q2, and then you have Q3, and then we have Q4 and Q5. So this is just just placing those states. So we can also move these states by dragging them. So then Q0 is the initial state. So for making Q0 as initial state, we have to right click on the state. So it shows us the option. So over here we can select it as start state and accept. So we see that the color of the state changes to blue. So blue indicates that that particular state is the start state. Now Q5 is the accepting state or the final state. So we click on this particular state. That is, we have to right click on it. It gives us the option. Here we can select accept state and accept. So it changes to green color, which indicates that it is the final state. Now these are the states. We've made it as final as well as initial. Now before we give the transition to these states, we have to define the various alphabets that we've used. So for that, we click on the set input alphabet. So here we can give our new alphabets. So in this Turing machine, we make use of 1, 2, and 3 because we have to design for the language 1:n, 2:n, and 3:n. So we are going to replace 1 with X, 2 with Y, and 3 with Z respectively. So the various alphabets that are used over here will be 1, 2, 3, X, Y, and Z. So we have to give that over here. We have to give the new symbols and add it respectively by using the plus symbol. So we see that 1 is added. Similarly, you have to add 2. Click on plus. Then similarly add 3. Then click on plus. Then we have X. So click on X and add. Then you have click on Y and then again add. Then Z. So these are the various alphabets that are used for this particular Turing machine. So we have seen that we've added all these 6 alphabets. So then you click on accept. So on the right corner we can see that it's displaying all the alphabets that we are going to use to design this Turing machine. So once the alphabets are done, now we start with the transitions. So for giving the transitions, we make use of this option. So here I need to give the transition from Q0 to Q1. So I first click on Q0 and then I click on Q1. Now it's going to show me what is it, right? So what is the input symbol and what is the symbol that has to be replaced and what is the direction of the head. So my input symbol has to be, so firstly I have to remove this. Okay, my input symbol is 1, it has already taken, and my 1 has to be replaced with X. So whenever I encounter 1, I have to replace that 1 with X, and I want to move towards right. So I click on plus. Okay, this is what it means. So then I click on accept. Right. So similarly, whenever I am going to encounter any number of 1s from then, I leave it as 1 itself. Okay. So and when coming back, whenever I'm going to encounter Y, okay, whenever I'm going to encounter Y, I leave it as Y. So on Q1, we will have 2 transitions. So for this, you click on Q1 and again on Q1. Okay, so in this case, we have to add 1, 1, R and Y, Y, R. So 1, 1, R is already added. So just add it over there. And then you have Y, Y, R. So Y, R. So then click on the plus symbol to add that particular transition and then click on accept. So we've seen that both these transition has got added. Now from Q1 to Q0, we have 2, Y, R. So Q1 to Q0 is Q1 to Q2 basically is 2 comma y comma r. So it is 2 comma y comma r. So add it to the current transition and click on accept, which means that whenever it is going to encounter the symbol 2, it is going to replace it with y. Right, so now on Q2, again you will be having two transitions. So I'm clicking on Q2 twice because that is the start and the end of the transition, the same state. So we have to, the transition on Q2 is going to be 2 comma 2 comma r and z comma z comma r. So we have 2 comma 2 comma 2 comma 2 comma r has to be added. So added and z comma z comma r. So this is z comma r. So here you add these two transitions and click on accept. So we see that it's got added. Now from Q2 to Q3 we have a transition which is 3 comma z comma l. That is, whenever it is going to encounter a 3, you have to replace that 3 with z and you have to move your head towards left. So here I give it as 3 comma z comma left. So I change the direction towards left. So I have to add this transition and I have to click on accept. So it gets added. Now on Q3, basically there are 4 transitions. That is 2 comma 2 comma l, y comma l, 1 comma 1 comma l, and z comma l. So we have to add all these 4 transitions on Q3. So here I have to add 2 comma 2 comma l. So it is 2 comma 2 comma l. Okay, so that's the first transition. The second one is y comma l. So it is y comma l. So I add that transition as well. Then we have 1 comma l. So we need to add that transition as well. And z comma l. So we have to add that also. Z comma l. So we've added all the 4 transitions. So click on accept. So after this, there is a transition from Q3 to Q0 on x comma r. So we have to add that as well. So this transition is x comma r. Right. So it is x comma r. So this is x comma r. So you add that particular transition and click on accept. Now from Q0 to Q4, we have y comma r. So I have to add that as well. So it is y comma r. So click on add, accept. So that's next on Q4 state, you will have 2 transitions, that is y comma r and z comma r. So you will have y comma r, that is y comma r. So add that, and also you have z comma r. So we have to select that as well. So z comma r. So add that particular transition and click on accept. So from Q4 to Q5, you will have b comma r, which means that when you would encounter a blank space, replace it with a blank space itself. Okay, like just there is nothing to change. So for blank space, you can click either on blank or you can click on epsilon naught. So I will be clicking on epsilon naught. Okay, and let's add this transition and click on accept. So this is the designing of the Turing machine, which recognizes the language 1:n, 2:n, and 3:n for all of those n which is greater than or equal to 1. Okay, so we have designed the Turing machine. So now we have to test it for some input string. So here our n is greater than or equal to 1. So the minimum string that this Turing machine should accept must be 1, 2, 3. Right, and it accepts all the strings of the pattern 1, 1, 2, 2, 3, 3 or 1, 1, 1, 2, 2, 2, 3, 3, 3. So it's going to accept such strings. So in order to check whether a particular string is accepted or not, there are 2 ways of checking. So the first way is that we have to click on this input string, set input string. So in this, there is no input provided. So let's first test for the minimum string, which is 1, 2, 3. So I've added the minimum string 1, 2, 3. It's simple. Just click on the alphabet and that particular input string will get generated. So now you click on accept. So here you've seen that we've entered the input string as 1, 2, 3. It's shown at the right bottom of the screen. So I have to test. So to test, I have to click on automata and I can click on test on input. So when I click on it, we see that there is a dialog box that comes, which tells us that the input accepted by automaton. So since we know that this is a Turing machine that is designed for accepting strings of the form 1:n, 2:n, 3:n for all n greater than or equal to 1. So here 1, 2, 3 represents a string of that form where your n represents 1. So this is a minimum string and it is accepted. Okay, so there is another way, so we can click on OK. So this is one way of testing whether a string is accepted or not. So we can even check it for a string that is rejected, right? So for that again, we can click on the set automaton input. So say if I want to check it for another string, say for example 1, 1, 2, 2 and 3, 3. So we know that this is also of the same form. Here n is taken to be as 2. So therefore it's 1, 1, 2, 2 and 3, 3. Now this string should also be accepted. So let's check for this. So here it might take some time to get reflected at the bottom. But our input string will be 1, 1, 2, 2 and 3, 3. Right, so it is seen over there that is 1, 1, 2, 2 and 3, 3. So to check whether this is accepted or not, we have to click on test on input. So input is accepted by this automaton. So this is how it is. So now let's check for some rejection string. Okay, so what we're supposed to be doing is so here let's check for another thing. Let's give 2, 2 and then let's give 3. Now this should not be accepted. So let's run this and test on input. So since it is not accepted, so here we can see that there is no dialog box that is going to show us that this particular string is accepted, right? So it is so even when you click on test on input, it doesn't show that the particular string is accepted. So this we can tell that the string is rejected basically. So if you want to try for another way, for another string, so we can give 1, 1, 3 and 2 for example. So if I want to test for this, I can give on automata and test on input. So we see that there is no dialog box which appears which tells us that that particular string is accepted. So basically this string is going to get rejected. Okay, so there's another method also for testing whether a string is accepted or not. So I'll show you that thing for the minimum string. So for the minimum string, so one way is click on file, then click on run. So when we open this, we open the simulation window. So when you open on the simulation window, here we can click on the start simulation. So when you click on the start simulation, it is going to, so we can see how the Turing machine is actually working. Okay, so we can even see how the states are changing and how it's moving from, how the transitions are happening. Okay, and finally after this, we can also see whether the particular string is accepted or not. So here it is showing that this string is accepted, which is 1, 2, 3. This was about exploring the tool of jFAST. So by using jFAST in this video, we were able to design a Turing machine which could accept the language 1:n, 2:n, 3:n for all and greater than or equal to 1. So we could see how the machine was able to accept the strings and also reject the strings. So hopefully this video was useful and all of you were able to gain something out of it. Thank you so much.